Hello and welcome back. Today we'll be doing question 3 from the 2018 MAT paper. Let's get started. For each positive integer k, let fk of x equal x to the 1 over k for x greater than or equal to 0. Part 1. On the same axes provided below, labelling each curve clearly, sketch y equals fk of x for k is equal to 1, 2, and 3, indicating the intersection points. Part 2. Between the 2 points of intersection in Part 1, the curves y equals fk of x enclose several regions. What is the area of the region between y equals fk of x and y equals fk plus 1 of x? Verify that the area of the region between y equals f1 of x and y equals f2 of x is 1/6. Let c be a constant where 0 is less than c is less than 1. Part 3. Find the x-coordinates of the points of intersection of the line y equals c with y equals f1 of x, and of y equals c with y equals f2 of x. Part 4. The constant c is chosen so that the line y equals c divides the region between y equals f1 of x and y equals f2 of x into two regions of equal area. Show that c satisfies the cubic equation 4c cubed, take 6c squared plus 1 is equal to 0, and hence find c. Pause the video to have a think, and once you're ready, restart to see if you were correct. Let's get started. Firstly, we'll move on to part 1 here, and we'll see that we have 3 lines, k equals 1, k equals 2, and k equals 3, drawn onto a grid here. K equals 1 gives y is equal to x, and therefore we simply have the y equals x line drawn for x is greater than or equal to 0. For k equals 2, we have that y is equal to x to the 1/2, and this is equivalent to the square root graph. This should be drawn as a curve that starts out higher than k equals 1, and then after the intersection point becomes lower. The pattern is repeated for k equals 3, and they all intersect at the points 0, 0, the origin, and 1, 1. Now, let's move on to part 2. Firstly, we'll notice that because y is equal to x to the 1 over k, we can write x is equal to y to the k, and this function will be known as gk of y. This allows us to equate the integral between 0 and 1 of fk plus 1, take fk with respect to x, and the integral between 0 and 1 of gk, take gk plus 1, with respect to y. These integrals are not identical, however, we may equate their numerical values since what we are performing is simply a reflection across the line y is equal to x. The integral on the right evaluates to 1 over k plus 1, k plus 2, and this is equal to the value of the integral on the left, and therefore the area between k equals 1 and k equals 2 can be evaluated to give 1 over 2 times 3, which is equal to 1 over 6 as required. Now, let's move on to part 3. In both cases, we'll start with y equals c, and we'll also have the relevant y equals fk. In the first case, this is y equals f1, which is equal to x, and therefore x is simply equal to c. In the second case, we have y is equal to f2, and this is equal to x to the 1/2, giving us x is equal to c squared. Now we can move on to part 4. Using a similar idea from part 2, we can write two equations for the area on either side of the line. And we can then equate them and also set them to be equal to 1/12. Simplifying the equation will give 4c cubed take 6c squared plus 1 is equal to 0. From here, one would be tempted to say that by inspection, c is 1/2, and therefore that would be the answer. However, one always needs to consider all possible solutions. In the first case, we have inspected that c is equal to 1/2, and therefore we can use the factor theorem to say that a factor of 4c cubed minus 6c squared plus 1 is equal to 2c minus 1, and we can then divide to find that the other factor is 2c squared, take 2c, take 1, and this is still equal to 0. Solving the equations gives that c is equal to 1/2 or 1/2 plus or minus root 3 over 2. This gives c is equal to 1/2 since c is the only solution out of the three that lies in the range 0 is less than c is less than 1. A second method is to reduce the equation to a depressed cubic. This is useful in cases where solutions are less clear and can be very helpful for more difficult cubics, especially when you do not have a calculator on hand. Here, we'll use the equation x is equal to t take away b over 3a, and we'll substitute in the values. The variable x is in this case known as c, and this is equal to t take away the quadratic coefficient, which is -6, over 3 of the cubic coefficient, 4, and this is equal to t plus 1/2. We can then substitute t plus 1/2 is equal to c into the equations and then simplify to give 4t cubed take 3t is equal to 0. This is a special case of a depressed cubic, and it is very easy to solve because it can be factorised into t, and 4t squared take 3 is equal to 0, and therefore we have that t is equal to 0 or plus minus root 3 over 2. We can then use c is equal to t plus 1/2 to give that c is equal to 1/2 or 1/2 plus minus root 3 over 2, and from here we have that c is equal to 1/2, as this is, once again, the only in-range solution. If you liked our video, please like and subscribe, and we'll see you next time for some more fun maths problems. Thanks for watching, and goodbye.